Okay, ladies and gentlemen, and welcome to today's class. So what we're going to be reviewing in this video are basically examples 9 and 10, which are in your textbooks, and the topics or the concepts rather that we're going to see in examples 9 and 10 are the following. The first thing we're going to do, and let me move my the little toolbar over here. So the first thing we're going to see specifically in example number 9 is how to calculate or use a calculator to evaluate trigonometric functions or trigonometric values of angles. So we're going to see angles that are not necessary, that don't necessarily have a special angle like 60, 45, 90, or 30 like we saw in our previous videos. And in the second example, or example number 10, says finding approximate angle measures given the trigonometric function of values. So the difference for these two examples that we're going to see in this class is that we're actually going to use calculators for them. When we have special angles like 30, 60, 45, 90, and 90, of course, 270 and 180, which are the angles that lie on the axis, is that they have specific measurements, and you can use them as reference to find something else. But in this case, we're going to have angles that don't necessarily have that. So let's go ahead and do the first example. And the first example is asking us to find the tangent of 466 degrees. So we're just going to look for the tan of 466. Now, you need a calculator for it, and you're going to find that, of course, in a scientific calculator, it can't be a standard calculator. And when you have your scientific calculator, you're going to go to the function or the key that says tan. And it depends on the calculator that you have. Sometimes those calculators, you might have to click on the tan function first and then write the number, or you can just type in the number and then write the tangent function. Now, if we look, we are going to say that the tangent of 466, once I use the calculator, is approximately approximately negative 3.4874. And again, I used a calculator to find the value of the tangent of 466, 4874. 4874. Okay. Now, this is A, example 9A. Now, what do we do for example 9B? Example 9B is asking me to find the cosecant of negative 313 degrees. Now, obviously, in your calculators, you do not have a function button or a button to find the cosecant directly, which means that you have to use the inverse functions or the identity functions that we've used throughout this course. Now we know that the cosecant is the opposite of the sine. So we're actually going to simply say, well, this is going to equal 1 over the sine of negative 300. Excuse me, let me fix that. 1 over the sine, 1 over the sine, 1 over the sine of negative 313. Now, one thing that you want to make sure when you're working with these exercises and you're using your calculator is make sure that your calculator is in the function that is degrees. It says DEG. If it's in the functions that says RAD, you have to do that usually by just clicking second, and there's a button that says degrees. But always make sure that your calculator is in degrees. It says DEG. Well, anyway, that being said, Since the cosecant is the opposite of the sine, you can look in your calculator for the sine of negative 313 degrees. So once you find the sine of negative 313 degrees, you simply divide 1 over the answer. So if I divide that, if I go to my calculator and look for the sine of 313 degree, 313, and then I simply divide 1 over that. So if we look for the sine of 313 or negative 313, you would get, and I'm just going to leave it at 4 decimal places. So you would get 1 over 0.73, approximately 0.73 14. And this is, of course, is the approximate answer. And what you do now, and let me specify that this is the approximate answer. So I'm drawing the approximate, writing the approximate sign here, excuse me. So now what I do is I say 1 over that number, and your answer is approximately 1.3673. So the sine of, or the cosecant, excuse me, of negative 313 is approximately 1.3673. 3673, and that's pretty much how you solve that one. Okay, so once again, because it's asking me to the problem is asking me to find the cosecant, and there isn't a key in the calculator that will give me the cosecant, I have to use the inverse function, knowing that the cosecant is the opposite of the sine. So I would rewrite that as 1 over the sine of 313. So the cosecant, I know that the opposite of the cosecant is the sine, so I write 1 over the sine of negative 313 degrees. In my calculator, I look for the value of the sine of negative 313, and that is approximately 0.7314. And then I divide 1 over 0.7314, and your answer is approximately 1.3673. If you do this and you get a slightly varied answer than that one, don't worry, because we did use an approximate value, and the answer that they're giving you is the closest one. Okay, so if you get like 1.3672 or 1.3674, don't worry about it, because it is an approximated value. Okay, so again, that's pretty much how you do that one. Now what we're going to look at in the second part of this video, which is example number 10, is when you have the opposite. So here I gave you, or the problems gave you the values, and you basically had to find the value of them. Let me just write the answers here so that way. So this, we said that this equals approximately. Let me just do that real quick before I get into the exercise, so that way we have our reference angles. Negative, the tangent of 466 by using our calculators was approximately negative 3.4874. 4874. And our answer for the cosecant, which is the one that we just did, of negative 313, was approximately 1.3673. So that is example number 9, which is in your textbook. Now, what we're going to see, as I was saying in example number 10, is we have the opposite. In these examples, I gave you the angles, or the problems gave you the angles, and you had to find the values. Now in example number 10, you're being given the value and asked to find the angle. Now it sounds very complicated and the wording of the problem may seem a little technical, but the reality is that it's quite simple. All we need to do is just kind of break down what the problem is saying. So let's go ahead and read it. And it says, find the smallest possible positive measure of z or theta. We call it z, but theta. Rounded to the nearest degree if the sign of z or theta equals negative 0.69 0.6293, excuse me, 6293, and the terminal side of theta or z in standard position lies in quadrant 3 where theta or z is greater or equal to 0 and theta or z is less than or equal to 360. So basically what the problem is saying is I'm giving you a measurement. I'm saying that the angle lies in quadrant 3. So let's draw that so we at least have a visual idea of what it's saying. Now I want you to find the angle or an angle that lies in quadrant 3 whose terminal side lies in quadrant 3, assuming of course as we have been that the angle is in standard position. So it's saying that the terminal side, and I'm going to draw a dotted line, is somewhere in quadrant 3. And this is, and I'm going to use the yellow arrows just to indicate that the angle or the value is going to be somewhere in quadrant 3. Where? We don't know yet, but we know that it's in quadrant 3. And we know that the sign of that angle is negative 0.6293. Now, when you have a value like this of negative 0.6293, it's not a special angle. That means it's not 45, 60, or 90 or anything like that, okay? So what we're supposed to do is, first of all, we need to find an angle. Once we find that angle, then we're able to find the what we're missing. Okay, so what you do, or the first step, is to actually go ahead and take this value, which is z equals, or theta. Sometimes it's called theta. Some other books call it z, or theta, is negative 0.6293. And we're going to look for the inverse sign. Now, we do that in our calculators. We're going to look for the inverse sign, and we're going to find the angle. And then we're going to use that angle and find the terminal side, okay? So the first thing is to find the inverse sign. Now, how do I do that? Well, you're going to go to your calculator, and above the sine, cosine, and tangent functions, there is something written in most calculators that says sine elevated to the power of negative 1. And what this is it's a function that is used to find inverse angles. So what you're going to do is depending on what type of calculator you have, in some calculators you'll have to click on the buttons first, and others you'll just write the number. But either way, what you're going to do to use this function is you're going to go to your calculator, and there's a button that says shift in some cases, or second, and you have to press that button and then press the sine, tangent, or cosine key. In this case, it's going to be shift, and then you're going to press the sine function, or depending on the calculator that you have, it says second. So depending on what you have, you might have to press second, shift, and then the sine function, or write the number and then just click second and sign. So it depends. So what I'm going to do is I'm going to go to my calculator. My calculator is actually the ones where I have to first write the number and then click on the sign function. So I'm actually going to write down the value, which is negative 0.6293. Okay. And then I'm going to find, or I'm going to use that to find my answer and round it to the nearest degree, because the problem is saying round to the nearest degree. So I press, and my calculator says shift, and then I press sign, and it gives me that theta equals, or the inverse sign of theta, the inverse sign of theta or z is it says equals 38.998. So 38.998. So the problem is asking me to round to the nearest degrees, so I'm going to round that to approximately 39 degrees. So this is going to be rounded to 39 degrees. And I found the angle. Now, whenever we're looking for reference angles, we call them alpha. In this case, I found the alpha, or the inverse sign of theta, which is 39 degrees. So the problem is telling me, if I go back to the problem, that the terminal side lies in quadrant 3, which is here. So what am I going to do now? How am I going to know? I know that it's going to be somewhere between, 181 and 269 degrees, right? But I don't know specifically what number it is. So how do I do that? Well, you're going to take the sign, or the inverse sign of theta, which we theta, theta. Um, we're going to take the angle of theta that we got here, or z, and we're going to add it to the reference angle that we use in quadrant 3. Now, the reference angle that we use in quadrant 3 is 180. Now, why am I going to add it and not subtract it? Well, because if I subtracted 180 minus 39, it would give me an angle that would be in quadrant 2, and that would make no sense, because the problem is saying that the terminal side lies in quadrant 3, which means I would have to add, in this case, 180 plus 39. So let's go ahead and do that. Let me go ahead and erase this, because this is really irrelevant to the problem right now. So the next step is to add, and we're going to say alpha, which is what we call that angle. Alpha equals, in this case, 180 plus 39. So we're going to say 180 plus 39 degrees, which is what we got, the inverse sign of theta, or z. And I know I repeat myself with the theta and the z thing, but it's just because I don't want students to get confused and be like, but he always called it z, now why is he calling it theta? It's the same thing. 180 plus 39 degrees, and that equals 219. So that would be my angle. And how would I express that as my final answer? For example, number 10, 219 degrees. I'm writing slow because I'm trying to make my numbers legible. So now that I know that it's 219 degrees, I simply write my answer. And let me move this bar a little bit so that way I have the space I need. I'm going to say then that the sine of 219, the sine of 219 degrees equals negative 0.6293. Six, 2, 9, 3. Okay. And that's how you would, well, actually, it's always approximately, because since, let me just fix this. It's approximately negative 0.6293. So that's pretty much how we use our calculators to either find the values of angles that have no special angle properties, and that's how we find you. And this is how we use our calculators to find the angles when we have a value of a specific trigonometric function given to us. So hopefully, this video will help you further understand the class. So stay safe, and we'll see each other soon. Bye.